Hi everyone, welcome to another tutorial video. In our today video, I will go over how to access, visualize, and download a satellite image from Landsat 9 by using Python. So let's get started. So the first thing that we need to do is, so let's create a new Jupyter notebook. I'm going to name it Landsat 9. And what we need to do is to import the essential library that we will be using for this tutorial. So the first one will be the EE library from Google Engine. So in order to access to the Landsat data, also we are going to use Geemap to visualize the data. And let's also use let me import numpy just in case, and for sure matplotlib, pyplot as plt. There is another two modules that we are going to import, which are called cartopy, CRS as CCRS, and the other one is cartopy Fisher as C Fisher. So once we imported all the libraries, we need to authenticate, initialize the Google Earth Engine. So in order to do this, we need to call Earth Engine authenticate, and also initialize. So I just run this line. So in my case, I already accepted, but you will need to it will send you like a specific link where you have to accept the permits, and then enter into your Google account, continue, and then just click all or enable all the links, all the permissions, then click continue, and then you will need to copy and paste the specific code into this specific it will appear you like a box over here where you need to paste the authentication factor. Then you click enter or hit enter, and you will be ready to continue. So the first thing, once you do this, the first thing that we need to do is define our region of interest, which is called ROI. And for this case, what we are going to use is matplotlib and cartopy to create a plot, and we should be able to define like a specific rectangle that we will be using for the rest of the video to download that specific data. So so in my case, I will be using a specific area of Manhattan. So let's create first the figure. Let's define the figure size as 10,8. Subplot This is just for the projection. Plate. Carry. This use the common projection 4326. Then PLT show, and over here we are going to type or create the figure. In our case, we are going to use this specific area in Manhattan. So let's create a variable that is storage the minimum longitude, which is this one, following by the maximum longitude, which is this one, comma 4. Then okay, this one is the minimum latitude, and following by the so let's first, this will be the area of interest. This will be just to focus in New York City, and then we can define a specific area within New York City. So this is the area. So let me just run this, and over here let's plot. Let's make the plot by using CatOpy. So set stand. We are going to use the ROI variable. The projection will be this one that we used before. And then let's also add some base map features into the plot. Add feature. So let's use this function see feature. Let's put the coastlines. Coastline, because this is like a line. So let's put this. Let's use a line width of 1. Let me just put a comma over here. So now you see this is New York City, and so far this is the coastlines. Let's also, let me just copy and paste this line over here and add the land. So this is specific area. So let's use a specific color to define this area, light gray, for example. So this is the land. And let's also, let me use another color, but let's copy and paste this line, blue, and over here will be ocean. So coastlines, the land and the ocean were defined. Just to let you know that for the first time, if you're running this line or this code, Python will download internally those coastlines, land, and ocean maps or base maps. So you will see like some red warnings over here. But yeah, that will be just for the first time. Then if you rerun again the code, it will disappear. Okay, so this is like the region of interest. Now let's focus, or let's create a rectangle where we need that we are going to use to extract the satellite image. In this case, just the red, blue, and green bands to get this natural image. So in order to do this, so we are going to use So let's define an area here in Manhattan. So let me just create this variable called Manhattan. And so let's define an area. So you can either use Google Maps and see the coordinates at the bottom to define the area. Or you can use Google Earth as well. So in my case, again, so we need to put the minimum latitude, minimum longitude, following by the maximum longitude, then the minimum latitude, following by the maximum latitude. And now what we need to do is so create the map's coordinates to create this rectangle, so you can see easily the region that we want to visualize first and then download the data. So Manhattan coords. So we need to create point by point, but so defining each of the corners of the rectangle. So let's define first the southwest. So it will be this one, comma, number 2. So I will speed up this process. Okay, so I just defined these 5 points actually to create the rectangle. So it will be first defining the southwest, the northwest, northeast coordinates, the southeast of the rectangle, and then to close the loop, we define the first one as well. So the first one again, so southwest. Then we need to put the long and lats in the same like in a list, in order, in the same order. So we can do this easily. Manhattan lats, and it will be let's use zip to do this. Manhattan chords. If I just run this, I just show you this. So we just created, we just got from this entire list of the coordinates just the longitude for each of the points, and the same for the latitude. So now we can use we can plot this into the map by using map ellipse. So let's pass just the x and y axis, coordinates, long and lats. Then let's define this rectangle with a red color in a solid line with a line width of 2. And just in case, let's put a label of Manhattan region of interest. And let's show this label into the map by using the legend. So now if I run this, let me just, it's a typo. So you will see that we plot New York City, but this one will be the region of interest technically. So will be the region that we will download and visualize first, and then download from the satellite, from Landsat 9, from the satellite. So let's continue with this. So let's first, with knowing that we just created this rectangle, this area that we want to download, we now need to get the satellite image from Landsat, from Landsat 9. So that will be like the second steps that we'll be following. So in order to do this, we can just look for on Google. We can look for on Google. Is this one over here? So we are going to use Landsat, the Landsat 9, the collection number 2, and the tier 1 from the level 2. So the revisit time is 16 days. It has the pixel resolution, or the image resolution has a pixel size of 30 meter resolution. And you will see over here the bands. So the numbers of the name of the bands, the minimum, the maximum, the scale, and the offset needed to convert these surface reflectance values and into surface reflectance values, and you will see over here some descriptions of each of the bands, and there's some additional information, thermal information. In the case of B10 and QA, and yeah, and over here there are also how to apply these scaling factors when you want to manipulate this kind of data. So we need this specific image collection when we are calling the Google Earth Engine to get the data. So knowing that, so let's first, if we go back, we click Python. So we will need to use this function again to scale the image and get the right values. So I just copy and paste and the Python version, and then what we need to do is let me just copy and paste this. We define this variable over here to plot in a matplotlib in CatOpy the rectangle, but for in this case Google Earth Engine. So remember, we defined the minimum longitude, the maximum longitude, the minimum latitude, the maximum latitude. But the way how this Google Engine is, we need to define the minimum longitude and the minimum latitude, and then the maximum longitude and the maximum latitude. So therefore, it will be something like these two are the minimums ones for the latitude and longitude, and then we define the maximum, which is this one over here and this one over here. So now this will be the coordinates that we're going to use to create this rectangle. So, and in order to create this rectangle in this Google Earth Engine, so we will need to use, so let me just create this variable rectangle, and it will be, let's call Earth Engine geometry, then rectangle, and then so let's pass this 4 coordinates. Automatically we'll create the rectangle in the specific format. So now let's get the Landsat data. So Landsat 9, let's create this variable, and this variable will contain some information. So the first one will be the image collection. So over here we are telling Python to collect the data, the Landsat 9 data, which is by using this specific command. So let me just copy and paste this over here. Then we need to specify that we want also to filter the image. So let's filter this search that we are going to perform by using this rectangle that we created. So over here we pass the rectangle. Also, let's filter all of this data that we're collecting based on specific dates. So let's use 2023, June 1st of 2023, from this one to June 30. June 30th. And then we are going to sort this. There is something here. This is supposed to, no. Let me just delete this space. And there's a comma here. Okay. And then we are going to sort this based on cloud. So we want to get the we're going to get all of the available images in this specific region. So this any image that covers this specific area, the entire area, and within this interval of time. And we're going to sort all of these images based on the cloud cover. So now if I run this and let's say I want to print the numbers of images. So number of images will be equal to, so let's call the variable Landsat, this one, period size. And then let's get the info. So if I run this, so you will see that there are just 5 images within this interval of time. That covers this specific area. So remember, those images are sorted by the cloud cover. So what we need to do is, getting the least cloudy image. So in order to do this, let's create this variable called Landsat least cloudy. And what we need to do is just pass the variable that contains all those 5 images, which is this one, and just get the first one. So the first one should be the least cloudy. And now that we did this, so we need to apply the scale factors. So let's scale the image, scale Landsat 9. So let's use this function, apply scale factors, and let's put inside that function this, basically the image. And then what we need to do is, let me create new cells. We are going to, now that we scale the image, we are going to select the argivans. So we call the variable that contains the scaled numbers. And we are going to select 3 different bands. So if we go back to the website, it says we want to technically plot or generate the natural color image, which basically uses red, green, and blue. So these 4, 3, and 2 bands, those 3 bands, it uses those 3 bands from the surface reflectance, and those are taken to generate this natural color image. So should be in this order, RGB. So it will be so this one over here. So let me just copy and paste in this order. First red, second green, and then blue. So 3 and 2. And now what we can do is the next step, which is plotting the satellite image. So in order to do this, we're going to use, let's go back, we are going to use this library. So Geemap. So let's create the empty map first by using this function. And then whatever we are going to generate, we are going to save it into this map variable that contains the interactive map that we can use to see the data. Before doing that, so we are going to clip. So remember, the satellite image is it covers a lot of area, and we want to just focus in this red rectangle. So let's use this red rectangle and a specific build function to clip all of these to clip the original data. So, and remember, those 3 are bands. So we are going to clip those 3 different bands. So let's call this variable that contains all the bands. And then we're going to use the function clip. And we're going to specify the specific area. In this case, we generated this Manhattan GEE rectangle. So if let's put this inside the parentheses. So we just clip it. Is this within this variable? And also what we need to do in order to make a really good parameter visualization, if we go back here to the website, we need to use these parameters. So we call these 3 bands, and then we call these 3 bands, and we specify the minimum and maximum value. So let's see over here. Let's run this. And now what we need to do is to call the map variable, and let's add the layer that will contain the satellite image for that region, which is this one. And then we also need to pass the parameters. So we are going to visualize the data in this order, and just using those specific min and max values. And let's name this Landsat 9 RGB Manhattan. And we need to, let's load the control layer control. So okay, so let me just comment this. And now, okay, if I run this and I call this map variable that contains the map, so this is the map. And the really good thing about this library is this GEE map library is that you can see the image interactively, so you can move around. In this case, the image is located here in Manhattan, and this is the least cloudy image that we found within that period of June of 2023. As you can see, there are some clouds over here in the image, but we got the natural image. Now what we can do is so here is you can visualize this actually, because I ran this before. But yeah, so you see here that you can, if you have like multiple layers, you can either like hide them or not. By default, we see the OpenStreetMap, and every single time that you like run this cell, so you will see automatically all the loaded layers. As you can see, there are some clouds. So now what we can do is we can probably let's increase the timeline. So let's use the whole year instead of just one specific month. So from January all the way to December. Let's rerun this again. Maybe what I can do is just change this to all year. Again, because I run this again, so I generate this map again, and I run this variable again over here. Remember, this variable should be run after you define everything. So technically, not only the clip and the visualization, but also this. Because you create this empty map, you are adding this layer, and then you are plotting the map. Again, so the really good thing about this library is you do this interactively, but every single time that you run or modify the code and rerun the entire image again, so you will need to scroll down and see the image. So you can see that now is a clear version of the image, and you'll see here Manhattan. So instead of avoiding like zoom in and zoom out, in this case zoom in every single time that you're running so this script, what we can do in finding Manhattan, so what we can do is just center the image by using this specific line. So let's center the image somewhere close to where we define the rectangle. So let's put this latitude and this longitude, and let's use a zoom equal to 12. So now we run this one, and this one. So you see over here the image, and every single time, again, if I run this again, so the image was zoomed where is located Manhattan, because I provided the coordinates and the zoom. If I decrease this to, let's say, 10, so you will be it will be in this position. So if you want to take a look at the image closer, so you will need to zoom in a little bit, but yeah, 12 is good. Perfect. So for this part of the video, we just visualize the data. So we create this rectangle and visualize and get the data, a clear as clear sky image. So by defining this rectangle and then calling Geemap to visualize the data. In the following video, I will focus on downloading the data and also how to visualize the data using Matplotlib and saving the image.